Hello, my name is Reid. I'm the Executive Director of the National Lighting Bureau, and today I am moderating 5 panel discussions. This panel is titled, Plants Have Feelings, Horticulture Lighting with LED. Our panelists are Corrine Wilder of Fluence Engineering, Leora Radetsky with Design Lights Consortium, and John Arthur Wilson, Lighting Design Labs. Welcome. John, the first question goes to you. Do plants have feelings?
Do plants have feelings? I would say this, knowing that my colleagues are going to have a chance to follow up. I would say insofar as feelings are the things that make us special, and knowing that my plants are very special, the more time I spend with them, and knowing that other cultivators feel that way about their plants, then I would say yes. By the transitive property, plants do have feelings.
Corrine?
Yeah, I mean, I grew up in a state park, so I grew up with a garden and I grew up all around plants, and knowing what I know about them, knowing what I know about some of the cultivators that we work with, playing music for their plants so that they get a better reaction, understanding how they really interact with different PPFD and lighting levels and even different spectras. Do they have feelings? Can they feel when you poke and prod and touch them? It's subjective, but I think every living organism has different ways that they react to things. So we'll put it that way and say, objectively, sure, why not?
What are the main challenges today in horticulture lighting?
I think there's a lot, but I would say one of the big challenges is getting objective information from manufacturers to cultivators. So finding, for example, the spectrum, finding out, exactly how much light output it produces, figuring out the spatial distribution, all the things that sort of affect how the lighting will perform in the space can be challenging to find. And so one of the things that we focus on with our horticultural lighting QPL is for every product that's listed, you can actually see the spectrum. You can see the intensity distribution, and you can see the objective data in terms of PPF or input power, and various parts of the spectrum that are enumerated as well, and efficacy.
Corrine, do you want to add to that?
As we get more manufacturers coming into the space and research being conducted, and then also more policy being produced from different states and utilities and organizations, one of the main challenges is how do we benchmark it? How do we really understand for lettuce versus cannabis versus tomatoes versus whatever you're trying to grow? Maybe it's sea beans. You have, what do you actually, what can we put out there as far as a standard horticultural spec that says this plant needs this much light at this different life cycle in this spectra, and that will produce the best result for you. And then as you go in and start to do that research and understand more about how these plants interact and how they react to the different inputs that you're giving to the system, how do you create policy around that that lets people be creative and grow the plants that they need to in the way that they need to, but also does it responsibly so that you have a nod to energy efficiency and design criteria and safety. Let's put it that way.
Sure. So what are the main crops grown today with horticulture lighting?
I feel compelled to say the crop that we speak the most of is the cannabis crop for indoor controlled environment agriculture. But I think everybody also understands the market is rapidly proliferating beyond that. And I think we are one small price signal behind carbon to rapidly shift what that looks like in terms of cost effectiveness.
Mm-hmm. Yeah, I think if I take it as far as what we sell into the market and what types of crops we're seeing the most of, cannabis is certainly one of them. It's gained a lot of attention just because of what's happened in the last few years with legalization and the fact that you actually have to in some states grow it indoor. So you have to do a CEA type of indoor environment, which use, except for some technology that's out there right now, you almost have to use artificial light. So whether that's HPS or LED or incandescent, whatever people use, I wouldn't suggest using incandescent, but you know, selecting a different type of light. So we have, I would say, 4 main markets. There would be, or applications: indoor, vertical farming, greenhouse environments, and then research. And as far as what's really been one of the main crops, I would say cannabis. There's certainly a lot of our vegetables are grown in greenhouses right now too. So tomatoes, cucumbers, lettuces are starting to be in more of a vertical type tier environment with some of these big indoor vertical farms that you'll see out there. Definitely go Google vertical farms, New York City, over in, where is it? The EU, there's a lot of product going out there as well. So cucumbers, tomatoes, veggies, lettuces, actually strawberries. There's a lot of strawberries out there now too. So those are some of the bigger crops that we've seen.
So we've heard a lot, of course, about farm to table. We also hear kind of container to table, where the food is grown vertically, perhaps in a container behind the restaurant. Mm-hmm. Is that beginning to take off, and where do you see that happening?
Yeah, we've seen it. I mean, here in Austin, where we're located, we've got a couple companies that are doing that. It's really about scale and how much you need. So do you want to be in a large greenhouse that's maintained, and do you have, or do you require enough product to elicit a whole greenhouse? Or do you want to keep it fairly small and tight, where when you stack multiple layers, so 3, 5, 7 layers on top of each other, you can be very economical with your space and grow in a container. There's a lot of challenges with that. We've seen them a lot more, but there's humidity in your environment that you have to maintain, because between, even, it's funny, you go into one of these containers and even between the bottom shelf and the top shelf, you'll have a vastly different microclimate within that container because it contains space. So the humidity, the temperature, the amount of airflow within each of those different levels is going to be drastically different. So you just have to pay attention to that and either use it to your advantage, like grow crops that would want a warmer temperature up top versus something that would want a cooler temperature at bottom. So you can definitely do that, and we have seen a lot more people starting to use that type of application. There's actually a lot of companies that produce fully built out containers ready to use, so you don't have to construct your own, actually, which is pretty cool.
Can you explain, one of you, the difference on plants, the different effects that LED has on plants as compared to sunlight?
So with LED, you can, for the most part, comprise any spectrum that you want, right? So you could have, you know, what we saw in the beginning, which was sort of this blurple red-blue fixture. Now you see a lot of white with red or far red. So you can customize your spectrum a lot more than you can with sunlight, which is basically equal luminant or equal spectrum. So I think the promise of LED, especially now that we're seeing more UV LEDs and more far red LEDs, is that you can really create a light that helps the plant that you're growing.
Okay, so that's my next question, is UV. What role does UV play in horticulture lighting?
So I'll take a little bit of this, Corrine, if you want to answer. So from the research that I did, for example, at the Lighting Research Center previously, one of the really interesting ways that you can use UV, especially UVC and UVB, is to combat plant pathogens. So rather than using pesticides, for example, to treat disease, like powdery mildews that you get in cannabis and a lot of other crops, you can actually use pulses of UVC to treat these diseases instead. So it's more like an organic type of intervention than a chemical intervention. I think that's really exciting. In terms of UVB and UVA, there are receptors in the plant. There's a UVB receptor in the plant called UVR8, which basically acts like a sunscreen for plants. So it introduces this effect, which can be beneficial. And with UVA, you can actually impact the phytomolecules or sort of phytochemicals in the plant. So if you want to, for example, enhance some chemical compounds like pharmaceutical compounds, you can do that with UV.
Mm-hmm. Yeah, I'll second what Leora is saying. They're finding new ways that it's impacting plant chemotype production every day. There's always new research going on that we find more and more things that are happening within that plant's own phytochemistry, and UV, far red as well, just like you were saying earlier too. So I think what I really want to stress is what Leora was saying on both the understanding the different types of UV and the different wavelengths, like specific nanometer wavelength can elicit a different response. So if you're talking UVC, and I'm not going to try to even guess the specific wavelength right now, but you can apply that in certain pulses or for a specific duration, and it will treat one of those specific diseases. So like powdery mildew and such like that. We've seen that happen in research before. It's also, I mean, think about it, how your own body reacts to being exposed to UV light. We get a sunburn and it stresses our system. So you would think about it in the same way like a plant, that if a plant is exposed to that UV radiation, they want to protect themselves. They want to produce a specific extra chemical. So it's a stressor to that plant system that will create or will cause it to produce more of a specific chemical. So whether we're talking about extra, what do we call antioxidants in certain plants, if we're talking about elevated levels of THC or CBD in some cannabis strains, that's something that people are studying more and more right now.
Leora, I saw a video, I'm pretty sure it was from the LRC, and it was a tractor pulling a trailer in a strawberry field. And it had UV on the trailer, and it was killing some sort of pathogen. Do you know what I'm talking about?
Yeah, it's called the Dragon, actually. Yeah, so the trailer's called the Dragon because you drag it behind your tractor, or because it breathes fire like a dragon. That apparatus has actually been replicated in several different applications in strawberries, for squash plants, for example, in New York 2 summers ago. And it's primarily used to treat this pathogen called powdery mildew, which can really devastate your crop production. But there have been really interesting effects on downy mildews and potentially other pathogens that can affect the crop. So it's a really fun device. In the case of that particular treatment, it's very time specific. So for powdery mildew especially, you have to have the Dragon or the UVC on at night so that there's enough dark time after the light is used so that you don't have this reactivation of the pathogen by light. It's called photoreactivation. So timing can be really important in those cases. So in some of those markets, the growers or the farmers pull the Dragon along right after sunset, and that way they have enough dark hours afterwards that it has a really good effect.
Okay, thank you.
Sure.
So as an industry, I think we've done a tremendous job of saving energy, especially in the last 10 years. Well, now all of a sudden we're growing plants with energy. So how does society overcome this increase in energy that we're using now to grow plants?
Great question. You know, I think one thing that's important to be aware of right off the bat is that while all energy comes from some sort of fuel source, not every fuel source is created equal. So the more that we can have clean energy, carbon-free energy or low-carbon energy, that's very different than, say, carbon-intense energy. And when we have this national dialogue, it's really important to keep in mind because different parts of the country, very major underpinnings of our financial economy are pinned to things average consumers don't feel like they have a lot of connection to, but we do through you know, the means of the ballot. But it takes a long time. So I always like to reinforce that to people. Growing electricity is going to be part of the future, but it's not all necessarily bad. The next thing I like to add is this. For a lot of utilities, they actually really welcome these sites coming into their territory. yes, it is a lot more power, but it's very predictable power, and it's a type that they can typically plan around. Sometimes there can be some immediate pain points with how they might have to build out a system, but by and large, I don't know a utility in the country who isn't welcoming CEA facilities the same as they're looking to welcome server farms or other large C&I customers.
What does CEA mean?
Controlled environment agriculture. I feel like that's kind of a soft peddling euphemism for cannabis, but it also is, I think, intentionally a broader definition because the industry is not just cannabis.
Okay, so California, do they welcome that? Because I read they're having blackouts right now.
Well, I always think it's careful not to tee these things up and make a super facile argument about it. California is not having blackouts necessarily because of the type of loads that is coming online with C&I. They're having rolling blackouts because of peaking issues. And so it's almost a false equivalency to sort of say, oh, well, it's just, this causes that. We can't do that. It's just way more complex. By and large, energy policy is going to address baseload on one level, and a different type of energy policy is going to address peaking issues. And that stuff's actually, it's playing out in real time. It's messy, but it's playing out in real time. There was actually a massive FERC ruling like this month that is going to upend the market and affect this.
So Leora, what's the DLC doing to help with this?
Well, we have a couple of things that we're doing. First of all, all of the products that are on the QPL have to have a minimum efficacy that is nominally about 10% better than the most efficacious double-ended HPS fixture. So all of the products do save energy compared to sort of the incumbent, which is HPS. And then you see a wide range of efficacies. There are products on the QPL that have an efficacy of 3.18, which is quite a lot higher than our 1.9 minimum. So that's one portion of it. The other portion of it that we're hoping that is helpful, as Corrine mentioned, in several states, regulators are putting in place energy efficiency regulations for cannabis facilities in order to try to control that load. For growers, lighting is part of the process. You definitely don't want to underlight or make them dim or make them reduce their lighting because you're so concerned about energy efficiency, because those growers simply won't succeed without the proper amount of light. And so those regulators in those states have put into place pathways to compliance, and in some cases, they use the DLC's QPL with a minimum PPE that's actually higher than ours. We have filters on the QPL so that licensees in those states can find products that comply with those regulations more easily.
What % of horticulture lighting today is LED?
Yeah, there's been a few market reports. The Cannabis Business Times produces a market report, like State of the LED Lighting Market Report every year. And so it's been trending up over the last few years. But what I would say is that it does seem that at least within the legal market, it's somewhere between 5 to 10% tops. And in some cases, people come back and say, no way, no more than 3% tops. So it's kind of fuzzy out there. If it's not LED, it's some other technology like fluorescent, like high pressure sodium, HPS, ceramic metal halide is being used a lot. In some cases, incandescent, and maybe that's more for night interruption or something like that, because sometimes you need a very, very low ppfd to just trigger a certain response in a plant. But that's what I would say is where it seems like it is right now. So we have a long way to go as far as energy conversion and saving.
Why is that? Because when I go to the trade shows, I see all of these purple LED lights. And I've just been under the impression that it has all gone, and especially with color tunability and being able to give the plant the appropriate spectra that they need at the appropriate stage, I would think LED would be taking over, but it's not.
It's some of its cost. LED is still fairly significant. The price is coming down for one, but it's still significantly more expensive, sometimes to the tune of honestly 3 to 5 times more expensive in some cases. So if you say a HPS fixture is somewhere between $250 and $350, and an LED fixture is somewhere between $1,000 and $1,500. that's a big chunk, because a lot of these margins that these producers are getting are very low, except for when you go to the cannabis space. So that's why cannabis has a lot more LED acceptance than other, commercial growers do. Also technology, just as far as educating the market on the benefits. So like you said, there's so many different, or Leora said, there's so many different ways that you can use LED technology to elicit a specific response in the plants. And that education to customers, just understanding how it can be deployed, how to apply it, why would I buy this purple one versus this white one, or this kind of pink looking light? There's a lot of companies out there. DLC is one of them. Resource Innovation Institute is another one. There's a lot of companies, and then each manufacturer is trying to do as best they can to educate the market on some of the benefits of using it versus HPS technology. And quite honestly, if you look at the total cost of ownership and an ROI, in some cases you can get much better than, say, 2-year ROI, especially if you start looking at
LED, because of the
LED. Yeah.
Okay.
Yeah.
And Leora, I assume that DLC is a big proponent of moving away from the legacy technology to the LED. Is that fair to say?
Of course, yes. Certainly it's not only more energy efficient, but for example, on the QPL, we have a requirement called Q90, which means that the photon flux maintenance of every LED in that product has to be at least 36,000 hours. So you have much longer life. Therefore, you have lower maintenance costs, and that can help with that ROI as well. So I think that the value proposition with LED is not only energy efficiency, but I think that life of the LEDs, of the fans, of the drivers, all of those are sort of baked into the QPL requirements that result in a more high quality product.
Okay. John, I'm going to put you on the spot. Let's say that it's 2030 and you are in, I'll take Austin, Texas, and you go to your local Whole Foods. Where will those vegetables have been grown?
Oh yeah, those vegetables are going to be, they will have been grown in a, if not super nearby regional indoor facility that is centered around strong environmental and race and social justice initiatives. That's where they're going to come from.
Okay. Leora, I'm asking the same question to you. And I want to ask, if they are grown indoors, what technology will be used in 2030?
I think that's a great question. So I actually think that one of the biggest challenges in hort in CEA is actually labor. And I think that this high-tech farm is not only going to have to be energy efficient and maintenance efficient in order for it to make sense for the growers so they can stay in business, but I think it's going to have to address some of these labor concerns. And one of the promises, for example, with LEDs and controls and cameras is that you can automate a lot of the processes that we rely on people to do. We can actually rely on IoT and controls to do. So I actually think that that's going to be a really big part of the future, this automation piece. And I think that with the promise of LEDs, that we can tailor spectrum for any crop. And there are even initiatives, for example, from FFAR to understand how we can genetically change plants to grow more optimally under LED versus sunlight or HPS. I think that's going to be very important to create productive environments that are profitable for growers and tasty and delicious.
Right, so yeah. GMOs can help, and we see many no GMOs. Do you think we're ever going to see no horticultural indoor lighting?
I hope not. We're asking for not as high of production if we do that, and we're asking for lower profitability for the grower as well. So there'll be less competition as well.
Same thing is true with GMOs, right? We could have higher profitability. We can have more plants per acre, and a lot of people like them, but there's a huge movement against it, and I just hope we don't get that kind of treatment from horticultural lighting. Corrine, what's your thought 10 years from now?
So my I think John and Leora are spot on. I really do think that we're hopefully moving towards more of a local system that can be scalable and can grow many plants at one time in one space, so that we reduce, usually we tend to go towards a very large footprint and then mass producing a specific plant in one particular area and then transporting it all across the country. I think we've seen through a lot of the different research that's being done and how our food systems are going right now, that is maybe not the best as far as the final product that's coming out. And that's also for both the nutrition of the product and the shelf stability of the product. There are some technologies that are showing like maybe extra blue light while in transportation can extend the shelf life of a product, which is really interesting. But, I would like to see many more smaller local footprint areas and companies producing within their own area, so that you can have better access to how do you want to say it? Like more fresh ingredients and grown within your own local ecosystem, which has another benefit, not only to your own community, but also to that ecosystem, and that, let's just call it, like, it could be engineered terroir. But that is something that I would like to see, and I really hope we move towards by incentivizing that type of environment.
Sure. John, closing comments?
Yeah, I think my colleagues here did such an awesome job elucidating and highlighting on all this new information, science with regards to the lights, how we're learning about the plants. And it reminds me, as they're sharing, and I'm just head nodding over here, it reminds me what a tidal wave of information to digest for your average consumer. People are up against it. It's always easier to go back to what you know than to have to stop and think and absorb all this new information, and we are bringing them a lot. Corrine highlighted, DLC is doing fabulous work to summarize this, to make it digestible. Resource Innovation Institute is working to speak cultivator language and utility language, make it digestible. But it's all about the people, and sometimes we just have to slow down and remember that we could be doing the Lord's work, but if we're going over their head, we're not connecting with them. So
great point. Great point. Leora, closing comment?
I really want to give a shout out to manufacturers like Fluence, who are willing to share their data transparently on the DLC's HortQPL. As I said before, I think that really makes a difference for growers, and also to utilities like John's utility, which incentivize products on the HortQPL in order to buy down that higher cost of LED to make the ROI shorter for growers. I think that there is some risk still for growers to change from HPS, which they've known for a long time, to go to LED, because we're just starting to understand how lighting in the system has an effect, sort of an interactive effect with each other. And I think that all of the stakeholders together are trying to make it easier for growers to take those risks in order to make this a more energy efficient process.
Corrine, closing comment.
Yeah, I think, thanks for that, Leora. I think my main thing, and just from what John and Leora both said, like, we've done several panels together, so we've got to know each other over the last few years, but this takes time. I mean, we've been in this field for a while now, and I would just say, don't be scared to ask questions, because it is vastly different from commercial lighting. I used to work with Universal Panasonic, and going from commercial lighting terminology to horticulture lighting terminology, there's a lot of similarities, but there's a lot of, it is different. So just to not be scared of it. And, we at Fluence, we're more than happy to answer any questions. And we try to be as transparent as possible. So I think don't be afraid of asking questions, and getting curious, because it is, once you dig in, it's actually really cool what you can find with the different technology and how it interacts with plants. And I think also just to reiterate and have people understand that when you're using lighting for horticulture, you're actually doing something with the light. You are growing something with this light, and the interaction within the whole ecosystem with the relative humidity and the light and the water and the CO2 in the air. So just remember that it's a whole ecosystem, and that the lighting is one of the very most important pieces to it, and it is very complex. So ask as many questions as possible and be curious.
Okay. Thank you all so much. This was a great session, and I know our audience will really enjoy it.
Thank you, Randy.